Welcome back, dear children. Myself, Sir Sunil, your chemistry teacher. How are you, students? Fine? I hope you all are fine. And you are enjoying the holidays now, okay? Okay, anyway, we have started the online class and we have completed 2 units. Now we are discussing Unit 3, Elements, Compounds and Mixtures. And yesterday I told you we will start this session by the topic water. Okay, students? So, all of you now take out your book and ready to watch this session carefully. Okay, students, here is our topic water. Clear? Nowadays, the summer time, always and within an hour, we want to drink water. Actually, do you know what is the chemical formula of water? Yesterday we have stopped our class in this chemical formula. Okay, everybody know the chemical formula, that is H2O. The chemical formula of water, that is H2O. A mixture of hydrogen and oxygen does not form water unless kindled. But water, what is formed by the combination of H and O, hydrogen and oxygen. But if you are not kindling, the water won't be formed. This evident from the following experiment. This can be proved by the following experiment. Invert a dry gas jar containing oxygen over one containing hydrogen. Clear? Here is the experiment. Just go through it. Clear? And first what we have to do, invert a dry gas jar containing oxygen. Invert a dry gas jar containing oxygen over one containing hydrogen. Remove the lids and wait for about 10 minutes so that the gas mix thoroughly. To mix the gas, hydrogen and mix, invert the jar over the hydrogen jar. Invert the oxygen containing jar to the hydrogen containing jar and wait for 10 minutes so that the gas mix thoroughly. Separate the jars and cover them. Separate the jars and cover them. You will not see the droplets of water here in the jar. By mixing the jar, by mixing the oxygen and hydrogen, we should get water. Okay, according to our study, we should get water. But here we won't get the water droplets. Why? Okay, now we are going to discuss. Now move the lid of one of the jars a little. Move the lid of one of the jars a little and kindle the gas mixture with a lighted matchstick. With a lighted matchstick, you just kindle it. You will hear a pop sound. You will hear a pop sound. Quickly close the jar and allow it to cool. Quickly close the jar and allow it to cool. You will see droplets of water on the inner walls of the jar. You can see that the water droplets in the jar. And you heard the pop sound. What is the reason? The pop suggests that a small explosion takes place when hydrogen reacts with oxygen to form water. The pop suggests that a small explosion takes place when hydrogen reacts with oxygen to form water. Does a compound differ in properties from its elements? Does the water differ from its constituent elements? It is there. Clear? Yes, it does. This will be clear from the following examples. The compound lead iodide is yellow in color. It is formed by the combination of lead, which is silvery, with iodine, which is violet. And also the properties of carbon dioxide are entirely different from those of carbon and oxygen. We know that the properties of carbon and oxygen, but by the combination of carbon and oxygen, we are getting carbon dioxide, CO2. but its property is entirely different from carbon and oxygen. Okay students, now we are going to discuss about the property of carbon and oxygen. Property of carbon and oxygen in the formation of carbon dioxide. Okay students, and a property, color and state. Carbon is black solid, carbon we know that is black solid, oxygen is colorless gas, but carbon dioxide, that is a colorless gas. Actually the property of carbon, that is black solid. Carbon is a black solid and oxygen colorless gas. By mixing up of these both, we are getting colorless gas. And also it burns or supports burning. Whether it is burns or supports burning. Carbon burns in air or oxygen. Carbon burns in air or oxygen. Oxygen supports burning, but by the combination of carbon and oxygen we are getting carbon dioxide. That is neither burns nor supports burning. Carbon dioxide neither burns nor supports burning. You can verify this one by yourself, that carbon dioxide neither burns nor supports burning by the following activity. Here we are going to do an activity. Okay students, carbon dioxide is formed when baking soda is treated with vinegar. When baking soda treated with vinegar, carbon dioxide will be formed. Take some baking soda in a small bottle and add a little vinegar to it. Light a candle and hold a folded piece of paper in a slanting position as shown in figure 3.4. Clear? Here is a diagram. Okay students, you just observe. Like this, you keep the candle, okay, candle downside. Light a candle and hold a folded piece of paper in a slanting position as shown in figure. Keep the mouth of the bottle near the upper end of the paper. Near the upper end of the paper, you see. Like this, you have to keep upper end of the paper. You will find that the candle stops burning. You can find that the candle stops burning. Since carbon dioxide is heavier than air, it travels down the folded paper and reaches the flame. Okay, carbon dioxide is heavier than air. That's why it goes down. The body which have the more weight, that goes down. Here the carbon dioxide is heavier than air. That's why it travels on the folded paper and finally it reaches to flame. Clear? As the gas does not support combustion, the flame is extinguished. As the gas does not support combustion, the flame is extinguished. Okay. The property of water are different from those of hydrogen and oxygen like carbon dioxide. Here we can see the property of hydrogen and oxygen and also the product water. See, in case of color and state, hydrogen is a colorless gas, oxygen also a colorless gas, but what we are getting? We are getting by the combination of hydrogen and oxygen a colorless liquid, that is water. And what about the burning? Whether it is supporting the burning? See, hydrogen burns in air or oxygen. Hydrogen burns in air or oxygen when kindled, and oxygen support burning. But the product what we are getting, that is water. Water neither burns nor supports burning. So what a difference in character and hydrogen and oxygen by the formation of water. Okay students, now we are going to discuss one important topic, atoms and molecules. Atoms and molecules. Okay, we are discussing in this chapter about elements, compounds and mixtures. We know that matter is not continuous. Matter is not continuous. It is made up of small parts called atoms and molecules. Matter is made up of small parts called atoms and molecules. First, we are going to discuss about atoms. If we continue to divide a sample of an element, if we continue to divide, suppose we are going to divide an element continuously. Here we can take carbon. We are going to divide it continuously, carbon element dividing into continuously, we will get what? We will get a small parts. We will get a small parts of carbon element, and we will get a part that cannot be divided any further. By dividing the carbon element, ultimately we get a part that cannot be divided any further. Okay? In the 7th century BC, the Indian thinker Carnot gave the name Paramanus to such ultimate parts. The 7th century BC, the Indian thinker Carnot gave the name Paramanus to such ultimate parts, the smallest parts. Later, some Greek thinkers also came up with similar ideas and named those parts as atomos. Those parts as atomos, meaning uncuttable or indivisible. They have given the name for it, the smallest part, atomos. Its meaning is uncuttable or indivisible. And in the 17th century AD, the British scientist John Dalton termed them atoms. Carnot given the name Paramanu, and later Greek philosophers, they have given for it the names atomos, and finally John Dalton termed the smallest particle as atoms. Clear? So, we will have the definition here for an atom. Please mark the definition. Please mark the definition. An atom is the smallest part of an element that takes part in a chemical reaction. An atom is the smallest part of an element that takes part in a chemical reaction. Atoms have the following characteristics. The atoms of an element are all alike. The atoms of an element are all alike. That means they have the same properties. Atoms have the same properties. For example, the atoms of hydrogen are all alike, and so are those oxygen or carbon. The atoms of hydrogen are all alike. The atoms of oxygen and carbon also all alike separately. So, here the atoms of an element are all alike, same. Next property is the atoms of an element are different from those of others. The atoms of an element different from those of others. For example, the atoms of hydrogen are different from different from oxygen or carbon. Okay, students, the atoms of hydrogen are different from those of oxygen and carbon. And another character is the atoms of an element show all the properties of the element. The atoms of the element shows all the properties of the element. For example, every atom of hydrogen will show all the properties of hydrogen, and every atom of oxygen will show all the properties of oxygen. Okay, these are the main characteristics of atoms. Main characteristics of atoms. Once again, we can define that the definition of oxygen, that is, an atom is the smallest part of an element that takes part in a chemical reaction. Now we are going to discuss our another topic, how is an atom represented. Okay, we'll see the time. It's the time to wind up the class. Okay, students, you have to read the chapter 2-3 times today itself. If you have any doubt, if you are facing any problems in today's topic, you can ask to me directly when class starts. Okay, then tomorrow we will come with the topic, how is an atom represented. Okay, students, till then, goodbye and have a nice day.